stream of consciousness as I go through here. So a big thing, which you've seen me mess up in the last couple of weeks, is just make sure you are reading the prompt and getting all the information that they're giving you here. Is someone chatting? What are you saying here? You can confidently assume one of the questions will be mostly A-B. No, I don't think you can confidently assume that at all. You're not actually going to get one of the A-B questions this year. I know normally you do. That's not going to happen this year. What am I doing? You got to lay flat. Okay. They did on this practice one. I don't know why, but there will be some A-B material on there, but obviously they're going to focus more on the BC stuff, I would imagine. And again, you will not be getting the same question as the A-B kids do. So it's misleading in this practice one. However, you should be able to obviously integrate from a graph like this and find areas. Let me see, make sure it's recording. Okay. So just read this carefully here. Okay. They're telling you function f, blah, 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 blah. It's got 2 line segments and a quarter circle. All right. And it's known that this point right here is on the graph. So they're giving me that. And all that means is we're going to have to use that somewhere along the lines. But 3, 3 minus root 5, which is right here. Okay. Also, to integrate this, so you all know that we've done this a bunch of times. If you have an area like this and it's a semicircle, like the area inside of that is pi r squared, right? But if you had a semicircle turned upside down, that's a semicircle, not a parabola, okay? Cool, and it had a radius of 2. So say this is 2, say this is like 3, and say this is 7, right? So that'd be a diameter of 4 right there. And you had to find that area under the graph. So not the area in the semicircle, the area under the graph, right? You really want this area in here. And we've done this before, and I imagine, you know, you guys all know this, but it's the area of the whole big rectangle, which is 4 times 2, minus the area of the semicircle, which is 1/2 pi r squared. So that's how you find that area in red right there, which is what the integral's finding, right? It's not finding the circle, it's finding the area under the circle. So the same thing's happening up here when you have to find the area under this semicircle, or quarter circle really, which is right here. It's going to be the square that's there. It happens to be a square, is a 3 by 3. So the area in there is 3 times 3 minus 1/4, since it's a quarter circle, pi r squared, and r is 3 there. So that's really 9 minus 9/4 pi. Okay. And while I'm on it, let me see. Oh, my kids have got out of the trampoline. Who knows what they're going to do? Okay, that's the area in there. And the area in, let me see here, in blue, in this triangle right here, which we're going to need, cool, is 1/2 base height. So the area in there is 1/2. The base is 3/2, and the height is 3. So that's 9/4. So that's the area in there. And then we got these triangles over here. So I'm just finding all these because we're going to have to find these areas anyway. So the area in this green triangle down here, that has a base of 3/2 and a height of -1. So the area in there is 1/2, 3/2, -1, right? And that's just -3/4. And then, what am I doing? Get up there. The area, I'm just going to use red again since it's always on the other side. But the area in this triangle over here, you all know is 1/2 times the base times the height. So that's just 1/2. So that's all the areas we need. And we need them for this very first question, because they're telling me the integral from -6 to 5 is 7, but like obviously we don't see -6 on this graph. They want to know what's the integral from -6 to -2. So there's some area back here. Let me erase this piece here at least. There's some area back in here, which I don't know. Okay, but I know the whole area plus that the question mark back there is going to be 7. So all they want you to do is say, well, I know that the integral from -6 to 5 of f of x dx is exactly the same thing as the integral from -6 to -2 f of x dx plus the integral from -2 to 5. So that's not too bad. And they're asking us to solve for -6 to -2, right? So that's just staying there. But the integral from -2 to 5 is just all those areas I found already added up. So that's 1/2. I'll do it up here. Minus 3/4 plus 9/4 plus 9 minus 9/4 pi. And they give you that 9/4 pi there to make it look a little weird, but that's not too bad. So 3/4 and 9/4 are going to make 6/4. These right here. That's really 3/2. So it's really a half plus 3 halves. That's 4 halves. That's 2. Plus 9, that's 11. So it's really 11 minus 9/4 pi. Okay? So all I'm doing is splitting this integral up here to -6 and -2 plus the -2 to the 5. And that's 11 minus 9/4 pi. And that has to equal, what they tell me it was, 7? Yeah, the total integral was 7. Which means if we just move all the other junk over there, we get that this integral from -6 to -2. Subtract off that 11, that gives you -4, and then you're going to add 9/4 pi. So there you go. That's part A. I don't know if y'all did this question or not, but that's how we do it. All right, so for part B, something I do want to talk about here, so which I talked about the AB kids. I don't know if you're going to see this. If they ask you to integrate a function like f prime of x dx from any number to any number, like 1 to 5, whatever, okay, that is just f of x from 1 to 5, right? And they'll tell you what f is, and you can find those values. But if they ask you to integrate from 1 to 5, and they put something inside of here, so a couple things they could do. They could just put like a 2x, or any number they want, like a 4x, right? Well, then the integral of that is 1/4 f of 4x, okay? Because the chain rule, like you got to undo that chain rule. So that's what's happening there. All right, if that doesn't make sense, let me know. You could also do like a u substitution there if you wanted to get rid of that. So basically, if the inside isn't just x and you're integrating just an f prime, you want to let the inside be u, and then du would be 4. You need a 4 on your dx, which means you need a 1/4 out front. So the integral becomes 1/4 the integral f prime of u du, and our limits then would change from 4 to 20 instead of 1 to 5, because I'm using this right here. If x is 1, u is 4. If x is 5, u is 20. Okay? And then you don't have to switch back. So it's 1/4 f of 20 minus f of 4. That's a 20 there. Okay? So that's one thing I expect them to throw at you. Another one, very, very similar. They could just like a function inside of here, like x squared plus 8 dx. Now, if they do that, they've got to give you an x out front. They could also make it parts, which I would not be super surprised with either, and we'll talk about that in a second. But they could give you something like this. This is just a u sub, and you know this is a u sub because u would be x squared plus 8, du would be 2x dx. You need a 2, a 1/2, and we can turn this into the integral, or 1/2 the integral of f prime of u du. And same thing, u is now going to go from 9 to 25 plus 8, which is what, 33? So you'd look like that. Okay, but really what I expect for you guys is a BC test question to have like parts going on, which would look something like this. They could give you just f prime of x here dx, and then they might give you like a 4x here or something like that. Okay, and then you're just going to let u hopefully be the 4x, which means du would be the 4 dx, right? And dv is just f prime of x dx, which means v is just f of x. And that integral is going to become, y'all see what's happening here, 4x f of x minus the integral of, actually, so since we got to do v du, they might make this like f double prime, I guess, because then this would be f prime, right? And then we would get v du, which would be 4f prime of x dx. That means this would be f prime too, right? And then you can integrate that, and you get 4x f prime of x minus 4f of x. And there could be limits on there, like from a to b, right? So anyway, I'm kind of rambling there, but that's, I expect, if you see, just be on the lookout for parts. If you see like a weird integral that has like an f in it and it's being multiplied by something, it's probably just parts, okay? I also want to put it past them to do, so remember we did like a table, like the tabular method? So let me erase all this junk. And again, I'm just making up stupid questions here. Like they could give you like x squared there like that, and that means we'd have to do parts twice. But if you just do a table method, if you remember this, we're going to put a 4x squared here, 8x, 8, 0, and then dv would be f. So again, they might make it like f triple prime, which looks scary, but it'd be f triple prime, f double prime, f prime, f, and they would match them up like that and change the sign of the second one. All right, and then they might have some table or something where they give you all the values you need. Okay, they could even, so something that I'm thinking off the top of my head right now is they could give you like the series for f. Like if they said, hey, the Taylor series for f is, and they might give you some values here, like 3 minus 4x, like centered at 0, plus 8x squared minus 5x cubed. Well, what this tells you is f prime, f double prime, f triple prime, f double prime, f prime, and f at 0. So you could use all those values down in here if you had to.
I have a question.
What's up?
If they give you that series, would you also have to consider the factorials that were divided out?
Absolutely,
like you'd have
yes.
to multiply by this.
Yeah, man. So that 5, remember, and that so it doesn't have to be tied into parts like I'm saying it, but I definitely think they're going to either make you build it or use it backwards. That 5 has to equal negative 5, has to equal the third derivative at 0 over 3 factorial, which is 6. So the third derivative is actually 30, negative 30.
Awesome. Okay, I just wanted to make sure that
makes sense. Yeah, just because there's no factorials doesn't mean they're not really there. They have to be there, right? So if they give you any Taylor series, it has to be the factorials. Okay? Now, a lot of times what they do is they make you build it, but sometimes they give you one and you have to recognize what it is. Okay. So anyway, I kind of went off on a tangent there. So this one's super easy. I'm going to show you. So just to make sure. It's 2, like obviously you all see we can pull that 2 out front, right? Not off the 4. We're going to have to put the dx here and integrate the 4 separately. But I'm going to do this because I need to make it the integral of just f prime. And again, if it has an inside part, you just do like a u substitution. But these are both from 3 to 5. Is that okay? I'll just do it down here. So that's 2 times f of x from 3 to 5 plus 4x. From 3 to 5. Then you're just going to plug in. So it's 2f of 5 minus f of 3, right? 2 times that whole thing. Plus, if you plug in the 4x, you get 20 minus 12. So this is just an 8. Okay, if you look back up on your chart, f of 5, they give you a graph of f, right? If you look up at f of 5 is just 0. And we also need f of 3, which you can't tell what that is exactly from the graph, but remember way back when they told us what f of 3 was right there. Okay. So it's 2 times f of 5 was 0 minus parentheses 3 minus, I forget what it was. Was it root 3, root 5? 3 minus root 5. I'm jumping all over the place here. Okay. Come on, pen. Boom. There you go. And I would really, really recommend, guys, if you have to write anything out and there's a lot of arithmetic, just leave it alone. Leave it just like that. That's a totally fine way to leave that. All right. D, you're just, I'm going to skip C for a second. I'll go back to C. Let me do it in order just in case someone's watching this video later on. Okay, let me get rid of this junk. They ask you to find the absolute maximum of G. So remember, to find the absolute max of any function, so this is part C, first thing you got to show is I need to know where the derivative is 0. Okay? You also need to show, and you can do it all in one sentence here, that you know G prime is f. If G is the integral of f, then G prime is f. Okay? And just to highlight this, to make sure we're okay, if G of x equal, this is like the worst thing I can imagine them giving you, something plus some integral, I'm just making this up here, of arctan of t dt, whatever, okay? Now, it's not going to be that complicated, but I'm showing this to you for derivative purposes. If they give you like a big integral like this, and they ask you to derive g, or you have to derive g for some reason, g prime is, look, that plus sign right here in the middle separates it, so it's just 2x plus the derivative of the integral. And the way you derive an integral, we've done this a bunch, is you plug in the top thing, what function you're integrating, and you multiply the derivative of what you plugged in. Right? Minus, you plug in the bottom of it times the derivative of what you plugged in, which would be cosine x. So that would be the derivative of that. All right. Now again, they're not going to be that crazy. But
I totally forgot that.
What's up?
I totally forgot that until you just said that.
All right, good. So that's something that the way you might see it. So right now they're making me derive this, right? Integral from -2 to x of f of t dt, right? So if it's just a number to x of some function, then the derivative is just that inside function. That's easy, right? Because it's you plug in x times 1, just plug in -2 times 0. This all goes away, and you just get f of x, right? But some things they could do just to make it look stupid, like they could put a 3 on that. Well, now the derivative is f of 3x times 3 by the chain rule, right? Again, -0 still. So that's one. So you might see that. That's a kind of a simple way to make sure you guys know the chain rule there. And another thing they could do is they could put the x on the bottom, or the 4, whatever, you put anything down there, up to a number. Well, now the derivative of that is f of 8 times 0 minus f of 4x times 4, which is really -4, f of 4x. So again, I think it'll be a lot more subtle than this whole arctan thing I just built down the bottom there. But they could switch it up on you, so that's just how you would handle it. That's all. But in this particular question, they're making it very straightforward, right? So there you go. Now all we need, again, to find an absolute max, you show, hey, I need to know where the derivative is 0. If it's not explicitly written what the derivative is, you should write that. So g prime is f of x. That's a pretty easy relationship there. And we're going to find out that 0 at x equals, hello, gentlemen. Very good. What you doing? Nope. Get back outside. Go wear yourselves out. We get x equals 0 at, or f of x equals 0. We have a graph of it up here. At -1, 1/2, and 5. So we're going to list those out. -1, 1/2, and 5. So that's the first step, right? You say, hey, I need to know where the derivative is 0. I found all those places. Now I just need to know the y value and see which one's the biggest, because a max can only happen at the critical values or at the endpoints. So we need to find, not f, we need to find g of -2, g of -1, g of 1/2, and g of 5, which was our other endpoint anyway. Now, because g is the integral from -2 to x, g of -2 is 0. And everything else just depends upon the areas in these triangles in the semicircle or quarter circle we had there. So g of -1 is the integral from -2 to -1. Well, we said the area is just a half, right? So g of -1 is just a half. G of a half, if you go back up to my picture up here, is the area in the first triangle, 1/2, minus the area down here, which is -3/4, right? So it's a half minus 3/4. What's up, guy? Whoa, screen. What's up? All the students are going to see you. Half minus 3/4, which is -1/4. Okay, right? 2/4, yeah. Okay, and then g of 5 is all those things added up together, which we already did. Remember we did that? That's just 11 minus 9/4 pi. And it turns out that the maximum is the biggest one of those. And maybe it's kind of hard to tell because you got the pi in there, but the max in this case is 11 minus 9/4 pi. So write a sentence explaining that, right? That's the biggest one of them. So you're right. The absolute max is, and look, say that g, say what x value, g of 5, and then say what the y value is. Okay. All right. I'm gonna give you guys a lesson in parenting here. You ready? Gentlemen, come here. Y'all can either go sit in your rooms for the next 45 minutes, or you can go outside and play. Those are your options. I don't want to hear it. No. Get outside. All right. Breaking hearts. No, you're not taking all that stuff outside. Go throw a ball. Go jump on the trampoline. Go swing on the swings. You get so many things to play with. Okay. And then I always had you guys write this too. Like, this is not super necessary as long as you showed all your work, but I made you write this just so you remember the process. I checked the endpoints, right? Because you got to do that if they ask for an absolute max. And where g prime, right? Where g prime of x equals 0. Cool. So that's that whole big mess. And then D, when I saw this question for D, I'm going to do it right in here. I really thought it was a L'Hopital's rule question, but it's not. You just plug it in and you get an answer. When you plug 1 into that thing, you get 10 minus 3 f prime of 1 is what you need right now. That's just the slope of f at 1. You can see there's just this line right here, right? At 1. Well, the slope of that is 2, right? Over 1 up 2, over 1 up 2. So f prime of 1 is just 2. Over f of 1, which also comes right off the graph. I think it's 2, right? F of 1 is, oh no, f of 1 is 1. My erase feature is not working. There we go. F of 1 is 1. Yeah, I'm not really sure why they put this in here and didn't give us a L'Hopital's rule question. So it's 1 minus arctan of 1. Go tell him I said if he doesn't get his butt outside, he's going to get it. Okay, that's D. Okay, let's go down to E. So now we're switching up to like a totally different question here. And just, again, they give us the derivatives, right? The second derivative, the third derivative, the fourth derivative. No. Just go jump and hit each other with balls and stuff. Go. Come on, man. I'm working. Get out. All right. They also give me, at 0, the tangent line. And the slope of this tangent line, you can see, is negative. What was that? Whatever. Is negative 2. Okay? So they don't say it here, but the slope at 1 is negative 2. The slope at 0, the first derivative is negative 2. And we can also see f of 0 is 3. So that really completes the whole chart there. They just gave me a graph for some stupid reason. Okay? Blah, 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 blah. Write the third degree Taylor polynomial for f. Well, everybody knows that the third degree Taylor polynomial, which I'm going to note as p sub 3, is the y value at 0, 3, minus or plus the derivative, first derivative, right, at 0 times x plus the second derivative over 2 factorial, which is just 2, times x squared, plus the third derivative, x cubed, and we could go to the fourth, but they just want the third degree, right? Yeah. So pay attention to whether they say the third degree or the first 3 terms or whatever. Degree means go out to that exponent. First 3 non-zero terms means you got to keep going until you get terms that aren't 0, and there's 3 of them. All right. H is now the integral of f. Use Taylor polynomial found in E to approximate h of 1. Okay. Well, h of 1. So you could integrate this, by the way, too. I'm just going to, to find a function h of x, but I'm just going to do the integral from 0 to 1.
Mr. Smith?
Yeah.
For the x cubed one, the third degree, shouldn't that be over 3 factorial?
I know exactly. Yes, sir. Thank you. Boom. There you go. Yeah, kids, learn from my mistakes and don't do that. I was just rushing and I forgot to put the factorial down there. Okay, thank you for pointing that out. So, h of 1, well, is actually approximately equal to this integral, right? Because we're stopping it. So, but the integral of p sub 3, just integrate it. It's 3x minus x squared plus 1/2 x cubed, right? Minus, it's going to become x to the 4th. I don't know if you can hear my son outside screaming at my other son. They're good kids, I promise. So you got to put a 4 down here. So that's the integral of that thing from 0 to 1. And luckily, when you drop a 0 in there, they're all going to go away. But when you put a 1 in there, you get 3 minus 1 plus 1/2 minus 23 over, I don't know, what's that going to be? 6 times 2 is 12 times 4. Is that 48? There you go. Or you could also leave it as multiplication. Doesn't really matter. So that's our approximation to h of 1. And then the last one is evaluate this integral when p is greater than 0. So this has nothing to do with the rest of this question. But because p is greater than 0, p plus 1 could be something like 2, right? So think about this. This is technically the integral from 1 to infinity of x to the negative p plus 1 dx. Okay? So when you integrate that, this is just the power rule. We're not doing anything fancy. This is all really, we did all this with like p series stuff. It equals, so we're going to, so negative p plus 1 is really negative p minus 1. So when you do the power rule, you're going to get x to the negative p, right? Because power rule says add 1. All right? But then we need to divide by that new exponent. So it's also 1 over negative p out front here, and that's from 1 to infinity. And it's possible like an integral like this could diverge, but because p is greater than 0, negative p is a negative number. So that really means this turns into negative 1 over px to the p from 1 to infinity. Okay, and technically, I guess we should put in like a b here, and I'm being lazy, writing a limit as b goes to infinity, right? So when you put that b in there, you get negative 1 over p b to the p minus negative 1 over p times 1. Well, if b is going to infinity, this whole thing here just goes to 0. And then you have minus negative 1, which is 1 over p. Sorry, there's a weird noise happening. What is that? It's like a wagon or something. I don't know if my kids don't have a wagon. I don't know what's happening. Okay. Anyway, let me stop this video. I'm just sitting here.